In this video, we're going to practice identifying the type of function we're looking at and then graph the function. So let's look at our first question here. Y equals the absolute value, that's what those bars mean, the absolute value of x minus 3. So clearly here we're looking at an absolute value graph. Now to figure out what this looks like, we know that we're going to have the standard V shape, and there's nothing inside modifying the absolute value part, so that's just going to be a slope of 1 in both directions. So one direction we're going up at a slope of 1, one direction we're going down at a slope of, in that case, negative 1. And the whole graph is shifted down by 3 units because that is going to be our y-intercept here. So when we plot it, it looks something like this. We shift the whole graph down from 0, 0 at the center down to negative 3. And then we have a slope of positive 1 going up to the right, slope of negative 1 going down to the center point on the left. Next problem is a square root function because we see a square root sign right in there. So y equals the square root of 4x, all that minus 2. So clearly here we're dealing with the square root function. Now on these, they're a little bit tougher to graph in your head, so a calculator is probably not a bad idea. However, some things that you should be looking for to make sure that you typed it in right when it comes out, you're going to be starting at some point and going up and to the right where your curve is slowing down. You also know that you can't go to the left because you can't take the square root of a negative number. So if you had x equals negative 1, you'd be taking the square root of negative 4, and that's just not going to work. So, knowing that your graph should look something like this, let's see what it in fact does look like when you graph it. Alright, so looks like this original guess here wasn't too bad. Kind of fits to what we're doing. It goes up a little bit faster than what I initially sketched, but same general curve. We see that it doesn't go to the left of x equals 0, because anything smaller than 0 for x is going to cause the term under the root to be negative. Finally, we have this y-intercept out here of negative 2, corresponds to where our square root function starts here at y equals negative 2 instead of the standard 0, 0. Move on to our next example. Identify the type of function and graph it. Now, we see a polynomial in the numerator and a polynomial in the denominator of a fraction. And what that's going to tell us is that we're dealing with a rational function. So, sorry about that. Whenever you're dealing with a rational function, you want to simplify it as far as possible and identify the holes and vertical asymptotes that you come across on your way. So, our denominator of x plus 3 is factored as far as it can go, but our numerator is a difference of squares. We have x squared minus 9, which means that we can factor it to x plus 3 and x minus 3. So let's do that. Once we factor it down, we identify a factor that is both in the numerator and the denominator, and that value of x that's going to cause that to go to 0 is what we call a hole. So we have a hole at x equals negative 3. The remainder, or the simplified version of our function, if you cross those like terms out, is just going to be y equals x minus 3. So this graph is going to simply look like a line, y equals x minus 3, with a y-intercept at negative 3 and a slope of 1. So let's graph that. Y-intercept here of negative 3, slope of 1, just like we expected here. However, we have to account for the fact that in our original function, x equals negative 3 is undefined. Sorry about that, I caught a small mistake here. At x equals negative 3, we see that the value of y is undefined, so we put a hole there, and otherwise the line continues to the left and to the right like normal. In our next example, y equals 5 over x. Again, we have a fraction. In the top we have a constant, in the bottom we have a variable. And so this is, again, going to be a rational function. However, it's a special case. We call that an inverse function when it's a constant over x. So you could call this a rational function. If you want to be more specific, it is an inverse function. And what that's going to look like is something with a vertical asymptote, because it's a rational function. Nothing factors, so we have a vertical asymptote when the denominator goes to 0, which in this case is at x equals 0. So if we plot that at x equals 0, we have the vertical asymptote where things approach it, and then we have this curve shape where something is moving towards and down, and then on the other side, coming from positive infinity and heading back this way. We also, in this graph, happen to have a horizontal asymptote at y equals 0.